Welcome to another Notes for Engineers video. I'm Alistair Cook, and today I'm joined by my friend Stephen.
Good day guys, this is Stephen Kang, working in a quite a complex vSphere environment, working as a VMware administrator.
I've asked Stephen to come in and do a video with us because he's implemented a Metro storage cluster, which the acronym MSC always gets confused with Microsoft clustering. So I've asked Stephen to come in and talk about it. He's built the whole thing and had lots of experience with it, so take it away, Stephen.
Yeah. Okay, let's get started with the definition of Metro storage cluster. It's a solution that combines synchronous replication based on array-based clustering. It sounds a bit complex, so to give you a to make it simpler, it's just a normal vCenter server cluster with several ESXi servers.
So an HA and DRS cluster with some shared storage.
Of course, yeah. So, but the difference between normal cluster and Metro storage cluster is that half ESXi servers and the other ESXi servers are in geographically dispersed.
So instead of being racks inside one data center,
yeah,
and all in one data center, they're two physical locations that are separated.
Exactly. Yeah. So I'll give you a quick diagram. So let's say there is a data center A, data center B, and of course these two are in physically different location. And I'll draw maybe
A couple of ESX servers
yeah,
on each side.
Yeah.
Of course, it scales well beyond two hosts at each side.
Yeah. And I'll just call it 1, 2, 3, 4. So as I said, these are ESXi servers are in physically in different locations, but they are managed by one single vCenter server cluster with HA and DRS enabled.
So historically, this has been a big no. Don't do this. Don't spread your clusters across multiple physical locations. We assume a data center boundary is also a physical boundary, but of course this is across physical boundaries now.
Yeah, that's it. So the thing is, to make this work, the storage underneath must be certified, so it should support what it's supposed to do.
So that's really where the magic in this is, that the storage is distributed across the two sites as well,
yeah,
and available at both sites.
Yeah, that's right. But before we go into storage technology, it would be good to go through the requirements. Several things I'll just mention. So the first thing is the supported storage connectivity. It's fiber channel over Ethernet and iSCSI. So if you're using NAS,
no NFS options here.
No,
it's all block.
It's all block, yes, but maybe in future they might support it.
Yeah, I guess there'd be some challenges around how locking works with NFS compared to block.
Exactly. The second thing is the maximum network latency between data centers should be less than 10 milliseconds.
And this is because it's synchronous storage replication, and that limits you, speed of light limits you in sort of 100 miles.
Yeah, as well as the vMotion. And of course the storage latency should be less than 5 milliseconds. So it's just telling you that distance between two data centers must be close enough.
So this is why it's a metro cluster. It's within one city or within one extended city, but it's not going to give you across one state to another, one country to another, other than possibly in parts of Europe.
No. Yeah, so that's pretty much it for the requirements, and let's talk about the storage underneath the technology. There are two designs. One is uniform and another is non-uniform. But in this video, we'll go through only uniform design.
Because that's what you've deployed.
Yes, and it's the most widely deployed design. So it's really simple. Or let's say the uniform design, what it's trying to say is ESXi servers in data center A and data center B have access to all storage on both data centers. So let's say here is the storage here, and data center B, A, and B here. And ESXi service in data center A has access to both storage units as well as 3 and 4. Well, it's getting messy, but
So the hosts are seeing routes not just to the array inside their own data center, they're also seeing access to the same LUN through an array that's in the remote data center.
yeah, so basically the SAN is stretched across the data centers.
Right.
So
And this, with Allure support, this would then allow the ESX service to be told which of the two physical arrays are currently owning the LUNs.
yeah, so
The ones available
so
through both.
let's say if the VM's running in ESX1, let's say it's using the storage here. Let's say it's getting a bit messy, but and obviously this will be retrained. Because Metro Storage Cluster is based on it's using synchronous replication technology, the exact same volume will be replicated. So that
But the copy over here is read-only since this copy is the
That's
read-write
right.
copy.
So a good thing about Metro Storage Cluster is because ESX servers in their different data centers also have access to this data store, you can vMotion this
VM from
here.
data center to data center.
Exactly.
Or in fact, at vSphere, that's one data center. It's just that we know they're physically separate.
Yes, exactly. So yeah, you need to know which ESXi servers are in which data center.
And that'd be typically a naming standard.
Actually, yeah. That will be helpful. Yeah. So you vMotion it here, the VM will be here.
And then access back through that path to
Yeah,
where the LUN resides.
exactly. But the problem here is that if you run the VM here, accessing the volume here, it means that it introduces extra latency.
Additional latency and tromboning of the I/O as well, because the replication's going to come back again.
Yeah,
Whereas
exactly.
if you're here, the replication only crosses once.
Yeah. So with uniform design, the best practice is to ensure the VMs are accessing the volume remotely. I mean locally, not remotely. Yeah.
So if this LUN normally resides at site A, you have the group of VMs that live on that LUN also normally residing at site A.
Yeah, that's right. But you can also have read-write volumes here.
So another LUN over here that's replicated in the other direction.
Yeah. Not good drawing, but yeah. So that's another possibility.
So VMs that normally reside at B. So this is still one big HADRS cluster, and you're still going to place load on all of the nodes in the cluster. It's not like you're going to set aside half of the nodes to be standbys.
To give you an example, let's say you were told to provision a VM in data center A, but now the VM owner asks you, oh, actually, I want that to be in B. Oh, I don't want the outage. And
Right.
there is a problem. If you use Metro Storage Cluster, all you need to do is vMotion,
Storage motion to
So
Right.
it's really flexible. So it's really easy to spread the workload. So let's say if these two are using 40% of, let's say, memory,
Yeah.
and only 10% here,
yeah.
it's easy to
rebalance
spread
across.
Yeah.
Yeah.
balance
Of course,
the work.
DRS, you don't want DRS to move the VMs across because it won't move the storage to go with.
Exactly. Yeah.
But it's a relatively easy manual process to rebalance.
Yeah. So
But that's not why you deploy Metro storage.
no, it's not. The purpose of Metro Storage Cluster is the automatic failover when there is a disaster. So, to give you an example with 3PAR,
And the 3PAR is the storage array that you've implemented this for.
yeah, that's right. So there is a witness server here monitoring these two storage. And let's say the data center, there is a power outage, let's say, then this is gone, right? What happens is the witness server detects that and tells this storage that, hey, this is dead, so what you need to do is any read-only volumes, you guys become read-write.
Provide up to read-write.
Yeah, so this will become read-write.
Yeah.
So the HA can bring whatever VMs were hit on here, data center B.
Yeah.
It'll be
So all the paths that went over to this site will now have failed, and the lines will trespass from the host side. The lines will trespass across.
Yeah, that's right.
There'll be a live copy up here.
So yeah, so that's just one example of disaster that.
There are lots of ways that a whole data center can be taken out.
You know, like if it's one ESX server failure, it's just a scenario of one failed the host in a normal
Standard
HA cluster. Yeah, so
and of course you're using must-run rules to group the virtual machines within the physical location. And HA will trample all over those must-run rules and will power them up over here, but DNRS will then move back again.
Yeah, once this data center.
So long as that data center's up, still up. I was thinking about the single host failure.
Oh, yeah, that's right. Yeah. Yeah. So that's how Metro Storage Cluster works. And the biggest advantage I can think of is it provides DR to applications that do not have application level DR. So, for example, Exchange, you can set up a DAG and
we should have you come back and talk about that as well, because there's a really interesting discussion around whether vSphere HA is the right choice for your applications. I think we should talk about that one.
Yeah. So, yeah.
So this is extending my HA cluster beyond just coping with a single host failure, so it can now cope with an entire site failure and bring things up at the other side.
But it also has some drawbacks, like for each ESX server, you can only utilize up to 50% of CPU and memory.
Because you've got this split 50% and 50% bin.
Yeah, so if it's a normal HA cluster, and if you use 5 of them, then you can set 20%. But assuming the memory and CPU size are the same.
And you're coping with one host failure. Here you're coping with 50% host failure.
50%, so so you need more money.
Money fixes many problems.
Yeah.
The only one it doesn't fix is the speed of light.
And another disadvantage is because it's HA, it doesn't know the application dependencies.
So power on sequencing is high priority, medium priority, low priority.
Yeah, so HA supports that, but it's not really guaranteed.
So there's just an ordering and a queue, and the queue is still executed sequentially.
Yeah, so for example, you set the database on high and application to medium.
Yeah.
But suppose the database gets piled on at the end of the queue, high queue.
End of the high queue. Yeah.
And the medium on the first queue, then.
And also the database server is going to want to replay its logs because it was an unclean shutdown, whereas the application server in front of it will be much faster to come up from.
So that's some
challenges.
Yeah, so that's something need to be discussed.
Yeah.
So that when there is a disaster, things can come back.
But that's no different than a normal HA failure, except for that we're accommodating far more failing at once here.
Yeah, exactly. So I really want to talk about SRM as well. So to differentiate between Metro Storage Cluster
and Site Recovery Manager.
Yeah.
How are we going? Let's do that in another video.
Yeah.
So come back again when we publish the second video to think about how Metro Storage Cluster is different to Site Recovery Manager.
Yeah.
And thank you very much, Stephen, for that. The Metro Storage Cluster, I think, is something that a lot of companies, in particular, I've seen a lot of financial institutions really interested in Metro Storage Clusters given their availability.
Yeah.
And it's good to just get the foundations of what it is. Where can people find you online, Stephen?
You can find me on Twitter, SSBKang, or on the blog, which is also SSBKang. So
ssbkang.com.
Yeah. So,
excellent. This has been Notes for Engineers. Check out notesforengineers.com for more videos. And of course, we'll be back with Stephen shortly.